If you are a C++ developer, you must be knowing about function overriding. Have you ever wondered why C++11 introduced overriding specifier? What's wrong with the old way? Hi, my name is Smitesh and welcome to my YouTube channel. In this video, I will be talking about why we need overriding specifier. We will also discuss one more specifier, which is final specifier in C++. So let's get started. Before we discuss about overriding specifier, we will first discuss about why we need it, what problem with the old technique. So consider you have a large code base and in your base class you have a many virtual methods. Now you are trying to override all the virtual method into the derived class, but by mistake something happened and your function signature, your overridden function signature is not matching with the base class signature. That means there is a signature mismatch. Now we have a question, will this code compile? If this code is compiled and when you try to call this method into the main or anywhere through the base class pointer, will it call to the derived class overriding method? So the answer is your code will compile, but because of the signature mismatch, it will call to the base class method. Now this is a problem, right? Consider you are writing a code and by mistake you missed something. Either you missed one parameter in the derived class which are existing to the base class. So this is a signature mismatch of the overriding function. So compiler is consider that function, that derived class function as a new function. So it will not give any compilation error. But when you call through the base class pointer, it will execute the base class virtual method. So this is a problem, and sometimes this problem is difficult to debug. To overcome this method, C++11 introduced override specifier. So let's first see about this code snippet. So if you see in this code snippet, we have a base class and there is a method display. It has a virtual function. Now in the derived class, we are trying to override this display method. Okay, but we forgot this const keyword, right? So now compiler is considering this as a new method. It is not considering as an overriding method. So when we execute this method into the main using a base class pointer. So here I am creating base class pointer and creating the object of a derived class and calling display method. So it will call this base class method. It will not call derived class method because there is a signature mismatch. If you see here, virtual void display const, here virtual void display. Okay, so there is a clear mismatch. So we are expecting to call this derived class method, but because of signature mismatch, it is calling base class method and it is not throwing any error. Then in the large code base, if we have a similar kind of situation, it is difficult to debug, right? So to overcome this, we need a overriding specifier. So in the next slide, okay, this is overriding specifier in modern C++. So the overriding specifier ensures that a virtual function in a derived class override a virtual function in a base class. So when you apply this override, it makes sure that your signature should match with the derived class with the base class. So both the derived class signature and base class signature must be same. Then only it will allow. So consider this code snippet. Here I am writing add method that has two argument. Here is const and in the derived class I am trying to override this virtual method add, but I missed one argument. and I'm applying here override, so it is giving the compilation error. So here we can easily track, correct? So this prevent error due to mismatch in the function signature or name. Consider we have a similar name, means we have a many method, but maybe some spelling mistake, something is there. So at that time also it has this error. So overriding keyword or overriding specifier is helping to prevent error due to signature mismatch. So this is the only reason they have introduced overriding specifier. We will discuss about one more specifier, that is a final specifier. Now final specifier is preventing or is preventing further overriding or virtual function or inherit from a class. That means consider we are writing a base class and we are at some extent at some extent we don't want derived class to override that method, means we want to prevent overriding. At that time we can use final keyword, final specifier. Or sometimes what happens, when we don't want to allow to inherit our base class, at that time uh, we can also use this final specifier to enter class also. Consider a scenario, we have a base class employer and we are inheriting a new class, derived class called part-time employer, part-time employee. We have an employee class, in the derived class we have a part-time employee. Now we cannot go further in the part-time employee, right? So we have to stop this part-time employee at some point. So at that time we can create a derived class part-time employee class as a final specifier using final specifier. So no one can derive this part-time employee class. So that will be the final class. So in this code snippet I am trying to explain using a I am trying to prevent only just method, virtual method. So consider this code snippet, base class we have virtual void display. Now we have a derived class here. We are overriding this display method of the base class in derived one, and I am keeping here final specifier. If you see here final specifier. Now if I am trying to create derived 2 from the derived 1, this will throw compilation error. We cannot override this display method furthermore. So this is a primary use of the final specifier. We can use this final keyword into final specifier into the class also, so that entire we can prevent entire class to inherit. So this is all about overriding and final specifier. Let's see in all this thing into the code. So let's discuss override and final specifier into the code. So I will create base class base, consider, then public method, public specifier, and create one virtual void. Consider I am creating same display, display and const. Here cout writing base display and then okay. Now we will inherit this base class into the derived class derive public base public. Then I am overriding, but I am missing this const keyword, okay, and cout derive the display enter. Now I am creating base class pointer. Base pointer obj is equal to new derive and calling display method and delete this pointer. Okay. Now let's build this and see what happens. Now execute. Look, it is calling base display here, base display, this one, but we have a pointer of derived class. It is not calling this display. Assume. Now consider if I write override specifier, it is throwing any error, right? Because it is telling that something is mismatch. Your signature is not according to your base class. So if I apply const, it is working perfectly. Now all the signature is perfect, right? We cannot write, we don't need to write this virtual here. So it is perfect, this signature till here, right? Now we build again and we run again. Yeah. Now see, derived display, it is calling this. This is perfectly right. This is correct one. So whenever you do overriding, when you using a latest or modern C++, you can use this override specifier. That is more helpful. So every time you override virtual method, you can use this override specifier. Okay. Now see final specifier. Let me remove this code. Okay, everything remove. Now as I discussed, final specifier prevent inheritance or overriding. So let's write base class base public. Okay, then here virtual void display same class, same method we will try, and here const. Okay, now cout base display and then now we create derived class, sorry, class derive one public base public void display const cout derived one and del. Now here it's working perfectly, right? Now what I do, I don't want this method, this display method of the derive one to be override further. So what I will do, I will write here final. Okay, now class derive 2 public. Now I am deriving, my base class will be here derive 1 public void display const. If you see, it is throwing compilation error, cannot override final function. it is writing, right? Cannot override final function. Okay, but if I change my base class to base, that one will work because there is no here final method, final specifier. So if you want your method to not override, you can use final. So this is the purpose of the final specifier. We will see how can we prevent a class also. So let's create one more code. Consider I have class employee public. I am writing here void display, same thing, very simple class we are trying to keep. See out display employee. Now I am inherit, or consider I create this as a pure virtual function, virtual void display 0. Okay, let's we create a pure virtual function. Okay, now class full-time employee and public, it will derive from employee. Okay, now here I am overriding method void display cout full time employee employee. Okay, and now I am creating part time employee. Part time employee with the employee class public employee void display cout part time employee. Now I don't want further inheritance of this class. So what I can do? I can do here final. Now let's try to final. Let's try to derived class employee hourly employee from the public part time employee. Look here, final class type cannot be used as a base class. Here we can see here, right, a final class type cannot be used as a base class. That means this is preventing to inherit it from this class. If I remove, the error gone, and if I keep, we are getting the error. That means we cannot do further inheritance when we apply this final method. So this one will be the last class because we have a final. So final specifier prevent further inheritance or further overriding. So this is all about overriding and final specifier. If you like this video, then share with your friend. Please subscribe my channel. Thank you.